Hey everybody, it's Mr. Canfield. This is the Chapter 4 review packet. And here we go! All right, what is the measure of KJL? All right, so it's asking me to find that down there. Well, hey, that's 72. So if we want to, wait, this is an isosceles triangle. So we know that this and this match. Okay. Well, what's 180 minus 72? 108. Okay. So these together are 108, but they're equal to each other. So take 108 and divide it by 2. Was that 54? So these are both 54 degrees. Great. Onward. Hey, wait, that's 54. That's a vertical angle. That's 54. Hey, wait, this is an isosceles triangle. And I know that, let's see, I have a single angle marked. I'll just put a double on there. I know these two have to equal each other then, right? It's an isosceles triangle. Well, what's 108? What's 180 minus 54? 180 minus 50 is 130. So 126? So cut 126 in half. 63? I would use my phone calculator, but it is currently filming this video for me. Oh, I just realized I forgot something. I'm gonna have to add that in before class. I'll just do it on the back. We'll do that at the end together. 126 divided by 2. All right, cool, yeah, all right. Wait, 180 minus 54. Okay, divided by 2. Okay, yeah, 63. Cool. Degrees. Okay. What additional piece of information is needed to show that def is equal to PQR? By ASA. So where's the S there? In the middle of two angles. Well, I have an angle 1 and I have a side. I have an angle 1 and I have a side. Also, then I need another angle. Specifically, I need this angle. So you could say angle D is congruent to angle P, or you could say that on the picture. All right, what's the perimeter of quadrilateral JKLM? All right, well, let's see. I see 60 here and 60 here. Oh wait, that means it's in 60, 60, then this is gonna be 60 as well. It's an equilateral triangle, which means all three sides of that triangle are the same number of 12. I also see here I have 9. I have those two matching base angles. This is an isosceles triangle. That was a bell, I'm okay. So we got 12 here, we got 12 here. It's an isosceles triangle, the base angles match up with the legs, bam, okay. So in that case, 12 plus 12 plus 12. If I'm just adding up the outsides, 12 plus 12 plus 12 plus 9. So 36 plus 9, so what, 45? It's not 45 degrees, I almost wrote degrees. These are side lengths. Side lengths are not degrees. All right, which of the figures appear to be congruent? So remember, congruency means like all the angles and all the sides match up. So like, this is perfectly flat here. This one's got a little, so one's not congruent to 2. One's not congruent to any of them. Let's see, 2. I think 2 and 3 might be congruent. Because 4 is, it's got different angles. So like if I draw this little square here, and I draw this little square here, they both have like a blank and filled in, a blank and filled in, like on this side. If we kind of think about that as like side A, and then your side B, it goes blank and then filled in, blank and then filled in, and it's bigger. And then it goes up and over and does the things. So I think these two are congruent. All right, so then for number 5, which statement is correct? Well, the two triangles are congruent by SSS. Let's see. For me, if I'm doing a multiple choice question like this, I'm gonna figure out the answer before I look at this. Like, so if I look at America's Got Talent, AGT, that was A to G, which was across the triple. G to T was across the double. So I'll go across the triple, across the double. So EQM. Oh, nope. Another way to do it is to say, well, then A and E go together. And G and Q go together. And T and M go together. So I need A and E to be in the same spot. So in this case, they both need to be first. They're not. This case, they both need to be middle. They're not. This case, they need to be the end. They are. G and Q need to be in the same spot. So they're both first here. Okay. T and M, they're both. Okay, so it should be this one. Or like whatever, however you want to get this one. AGT, so A is supposed to go with, no, A and M don't go together, so yeah. This is the only one that survives the process of elimination. All right. Next one, part 6. I drew I copy pasted the diagram for each part of the question instead of just giving the diagram once. So if BAC is congruent to DCA, so BAC, DCA. All right, and then it's asking about ABE, CD, CDE. So ABE and CDE. And since they're together here, I was going to draw them separate, and then I realized that is actually going to be beneficial for us to look at them as a pair because they have this vertical angles thing going on in the middle here. And hey, look, now we got angle, angle, side. If you need more help on that, I go into a little bit more detail in my other video that should be posted basically at the same time as this. Let's see. If AB is parallel to CD. So AB and CD are parallel. That means bam, bam. That means, well, let's see, ACD, ACD. A, C, D. Oh, I didn't leave enough space under this one. Sorry about that. I meant to, whatever. Okay. A, C, D. And then C, A, B. So these are parallel. So I'm trying to find angles in these two triangles. Oh, hey, hold on. That's a shared side. So hopefully angle A and angle C are equal to each other. Well, hey, these are parallel, right? That's two parallel lines cut by a transversal. Alternate interior angles shows us those are the same. So alternate interior angles, and then down here we can say this is side angle side. So I'm not sure which one that question is actually looking for. I think both are good answers. Well, I think both are necessary. Okay. 6C, if BD bisects AC, pause. This bisects AC. That means AC is cut in half. I was going to put a single dash, but I can't. There's already a single dash. So I'll do double dash. AC bisects BD. I'll do triple dashes on that. What theorem can be used to show that ABE is CDE? So ABE, CDE. Well, look, all the sides match. So one, you could say side, 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 because that's what we just finished marking. Another one you could do, because we have vertical angles here in the middle, is you could say side, angle, side. Either one of those would be valid. I would accept either one. All right. And we have this nightmare. All right. What's the measure of MNT? MNT. So we want to know this guy right here. Okay. And we want to know what the distance from M to R is. Okay. This is not asking for proof. So if you can tell something's true, then you're probably good. So meaning you can tell that's 6, that's a 6, that's a 4. Like if you can tell this from the picture, cool. So MR is 20. Similarly, we can tell that 25, there's the 35 in here. It's going to be reflected. Like if you can tell that, great. Oh, hey, so see the lines here? So now I'm going to like do more proofy kind of talk. So here are the lines here, which means we have an isosceles triangle. So that's 25. So this is 25. Cool. This 35 right here means that down here, well, 90 minus 35 is 55. Okay. And if that's 55, then this is 125. I'm trying not to just like, I already know it's going to be symmetric and that's going to be 125, but I'm trying to like slow myself down and be like, okay, what else can I figure out here? Well, that's 125, so that's 25, so that's 150. So then this right here is 30. And let's see if that makes sense. This is 65 and 25. Yeah, that's 90 and that's nice. So like we've got this big triangle here that works out. And we know this is 90 because that's how straight lines work. So if this is 25, this is 25. Wait, no, that's not going to work. But I could say, I know this has to be 65. So that gives us enough information. Yeah, because now we have side angle that the two big triangles are equal to each other on either side. Which means this, and this side is equal to itself in the middle here. So that means that the sides at the bottom have to be equal. So this is 4 and this is 6. Ignore that this is shorter than that, like whatever. And then, so we're good on that. That's got to be 20. Now I'm still working on getting this one from nothing. Oh, wait, I'm sorry. I feel so silly. We have this isosceles triangle right here with the BAM and the BAM. So that's 55, so that's 55. Oh, wow, I made that way harder than it needed to be. It's 125. Okay, I did way more work than I had to. You're not always going to see it. All right, next, BAM. Which triangle is congruent to KLM? All right, I almost didn't include this one, but it gets really easy when you just go, oh, wait, hey, look, that's 3 spaces. Hey, that's 4 spaces. This is the longest side in this one. This is bigger, is not that one. All right, now 3 spaces like this is different than going across 3 like that. It's a different length. And so this has a go across 3. I'm ignoring the obvious one. This doesn't work. This is a 2 and a 1 that it's moving. This is a 2 and a 2. Like they're not moving the same distances. The book wants you to do the distance formula, but I'm showing you that you can do this without the distance formula. You can just kind of size it up and kind of count things out since it's on the grid. But look, 3, 3. 2 and a 1, 2 and a 1. 2 diagonal, 2 diagonal. So if I want KLM, I could say triangle, and I need to be careful. I need to label it in the same order. So if I do K to L, sorry about that. Okay, so K, so we need the triple, not the triple, the long piece. So it's either going to be HG or GH. So K, oh, I'm dumb. Sorry, KL. We're doing the end of this across the 2. So the end of this across the 2. Okay. So that's going to be GJH. Okay. And then it's like J to H goes across the short one, just like L to M goes across the short one. Okay. To show that RQP is congruent to PSR by SSS, what must be true of the value of X? Well, we know that this and this must be congruent to one another. If the triangles are congruent, look, you're guaranteed that. So there, we've got SSS. All right, so now we got our next one. It says prove QMP is congruent to RNP. Definitely could expect this level of proof or any of the ones from the homework. So QMP, RNP. Well, look, we got a side and, or that's not a side, that's an angle. We have a side and an angle. And then we have an angle. So we have a side, an angle, and an angle. So that's going to be angle, angle, side. So I already know how I'm going to end this. I'm going to say, so triangle QMP is congruent to triangle RNP by angle, 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 side. Yep. Box. I already know that's my last sentence. So the thing that you can do to help yourself is, since I'm going to be using AAS, I'm just going to do AAS over here on the side. Let's just figure, okay, so, well, let's start with this one. This angle Q here. If it was, well, no, we'll get there. So angle Q is congruent to angle R. And I can say that because Q and R, there's no other angles at their spots. So why are they congruent? Because it was marked on the picture, it's given. So this angle here, now I need to be careful. So I could do QPM, angle QPM. I can't just say angle P and angle P, because in the first diagram, there are 4 angles at angle P. Which ones are we talking about? So QPM is congruent, and I need to be careful. I did QPM, that was first, last, middle. So to name it again, I'll have to do first, last, middle. So RPN. Okay, then S, our side. Okay, here's our side, QM. So side QM is congruent to side, now careful, so QM is first and second, so RN is first and second. There we go. Oh, I proved that angle is, oh wait, I didn't prove this one. I didn't prove either of these. Shoot, sorry. QP, all right. Why are these angles equal? Because they're vertical angles. I need to say why I know they're equal. I knew that was equal because it was given. I knew that's equal because it's vertical angles. I know this is equal because it, oh, it's got the marking. It's given. That's the checklist. You go, okay. I knew it was AS. Here's the 3 pieces. Laid them out. Bam. Done. That's a proof. All right, 11. Which statements are true? Select all that apply. FGK is congruent to FJK. We need to get away from they look the same. Oh, it says triangle FGK and FJK. Interesting. I don't know about that one yet. I mean, it looks the same, but we don't want to go off of that. FG and KG are the same. I don't... So if you're like, well, yeah, they look the same. Yeah, they drew it so it looks the same. But these are marked as being the same. Here's H. These are marked as being the same. But there's nothing in here that says this can't be where point K is. Because there's no marking on that. So this is not guaranteed to be the same length as that, which also means this is not guaranteed to be the same angle down here. But are we guaranteed to be the same triangle? So we are guaranteed that these 2 triangles are the same because they have the one, the double, and then they have this shared side, which means that this angle here and this angle here do have to match. And this angle here and this angle here do have to match, and this angle here and this angle here do. So all those angles have to match in the top half and the bottom half. So we are guaranteed that these two angles are the same. And then in this triangle, they share the double. So yeah, these FGK and FJK are congruent triangles. I got SAS in there. So that's true. FG and KG do not have to be the same, as we talked about. GKH and JKH. So even if it's moved, we have a shared side here. I'll just put 4 on it, whatever. We have a shared side here, and then this angle H, the two angles at H are the same because of what we talked about earlier. So yeah, then bam, 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 that's SAS. These two sliver triangles, no matter like how they're wedged, those have to be the same. So GKH and JK, yeah, that has to be the same. And then GFH, JFH. This really should be the first part of this, because that, if you can, since we can show those have to be the same, we're good. That's the only one of those that doesn't have enough information to say. All right, the last thing I want to talk about is I want to say, I'm just going to make up a terrible equation right now. I'm going to say solve sine of x, maybe 5 minus sine of x is equal to ln of x plus 3. I don't know. Hopefully this works. So to do this, hi computer. To do this, we are going to go to Desmos. All right, hi Desmos. So remember, if this is my equation, 5 minus sine x, I am not able to just go in and type equals ln x plus 3. This is not the way that we handle it. Instead, what we do is we graph the 1. I like to write y equals, graph the 1, and then ln, oh, nope. I like to write y equals ln x plus 3. All right. They don't touch. Do they never touch? Does it never happen? No, it happens. Oh, there's gonna be a lot of solutions to this. Oh, this is a non-trivial question. All right, well, hey, here's an intersection. All right, key thing here, our x value is the number. So 51 point, however you want to round that. So I do 51 point, I could do 9.5. I could do, if I did 949 and wanted to round to the 9 there, that's 6 rounds it up. So it'd be 950, you could say 9496, whatevs. You say 0.9, but that x value is the answer. So back to this. X is approximately 51.95. Okay. Oh, sorry for the loud noise. I think that was everything we need for the test, and I hopefully don't have to make any edits. Okay, bye!